Hello, it's Mr. Primmer here, and right now we're going to have a big study session for grade 10 chemistry. So I know in this class that I'm teaching right now, you've already written the grade 10 chemistry test, so it's a time to take that up. But you can also use this video to help study for the final exam. And so I think it's a really important thing to just make sure that you take your test and you go through this content and make sure that you really understand it. Because if you go on to grade 11 and 12 chemistry, you really need to have a good foundation. And also it's just a good learning experience too. If you didn't do that well on the chemistry test, don't feel bad about it, but instead just try to be proactive and try to go over the content and make sure that you learn the content so that you'll do very well on the final exam. Okay, so let's go through some of the test. So first of all, let's see what the first question was here. Okay, so we're not going to go over the multiple choice, we're just going to go over the short answer section. So the first one was draw Bohr diagrams for the following atoms. So we had aluminum and boron. So aluminum, we look on the periodic table. So first thing we need to do is look at the number of protons and neutrons. So right here it has 13 protons, and you can figure out the number of neutrons by taking this number and subtracting the atomic number right here. So 27 minus 13 would be 14. So let's fill that in right now. So we'll put aluminum, the symbol for aluminum, and we'll put has 13 protons, so 13p and 14n. Okay, then we're going to put a little circle around this. And then how many electrons is it going to have? Well, it's going to have the same number of electrons as protons, so it's going to have 13. So we're going to draw the first energy shell. And I apologize for the low quality Bohr diagram that this is going to be. But remember, only 2 electrons can fit in the first energy shell, so we're going to make another one around it. This one, what is the max number of electrons that can fit in this one? It is 10. And remember, they always partner up with each other. So now we have 10 electrons altogether, so we need 3 more. So we can draw one more energy shell. And on the last one, if you don't have enough to fill it up, you go around like this without partnering them up. Okay, so a little bit messy, but that's what it should look like. Okay, the next one is boron. So let's go up and look at the periodic table and see where boron is. So boron is right here. So it's going to have 5 protons, 5 electrons, and how many neutrons? So it says 10.8. What is that all about? So you're going to just round it to the nearest whole number, so 11. So 11 minus 5 will be 6, so we'll have 6 neutrons. Okay, so let's go fill that in right now. So we'll put B for boron, and then it has 5 protons and 6 neutrons. Draw the first energy shell around it. 1, 2, second energy shell, and 3, 4, 5. Okay, so that is the first question. Let's go down to the next one. And it's always important to read the questions carefully. When you're watching this video, one thing you can do is pause the video before we actually take up the questions and try them out on your own. So that could be a really good way to study. Or if you're just taking up the test and just watch it straight through. But when you're studying for the exam, it might be good to go through this video, pause it before the questions, try them out, and then unpause it and watch the solution. Okay, so potassium ion. So remember, it's an ion, so that's its charged form. So basically, it's the form where it's going to be happy. So let's look at potassium right now. So it's right over here. So it has 19 protons, and if you look over here, 39 atomic weight. So 39 minus 19 is 20, so 20 neutrons. And it has a charge of +1. So let's fill in this information. So we have K, and then it has 19 protons and protons and 20 neutrons. Okay, and we can just start doing the normal Bohr diagram. So there's one energy shell, here's another one. So now we're up to 10 electrons. And remember, we want to make it happy. So remember, what's the key to a happy? I just have to do a little face for you guys because I know you'll love this. Okay, we want to be happy like this guy. What does it take for an electron to be happy? Well, it takes how many electrons? 1, 2, 3, 4, 5, 6, 7, 8. There you go. That guy's pretty happy. He has 8 electrons. So that's how you make an electron, or I should say an atom, happy. So with this one, it usually has 19 protons and electrons, but its charged form will have enough electrons to make it happy. So here, we're just adding the final electron. So now we have 18 electrons. We have 2 in the first shell, 8 in the second, and then 8 in the second. So it's 18 altogether, and it's happy. So therefore, it's going to have a charge of +1 because it's missing 1 electron. And if you're missing something that's negative, you become positive. Okay, so that is the first one. Oxygen, let's take a look at oxygen. So go up to the top. So oxygen is 18 protons, and you can see that it has an atomic weight of 16, so therefore it will have 16 neutrons as well. And it has a charge of -2, meaning that it has, usually it has 6 electrons in its valence shell. So here we go. So so 8 protons, 8 neutrons. Draw a little first circle around this. Oh yeah, I should say 2. Have I been doing it? Oh yeah, usually what happens when you do these is you put a little circle first and then start. So as you can see, I already kind of messed some of these up. You're supposed to put a circle first and then put the first energy shell. Whoops. Okay, so let's see what we do here. So I'll fix it this time. So first energy shell will just have 2 electrons. Second one, now, well, let's start by seeing what it normally is like. It normally has 1, 2, 3. So altogether right now it has 2, 3, 4, 5, 6, 7, 8 protons, or electrons. Oh boy. So what is it going to do? It's going to add another 2 to become happy, like this. So that will be its ion. And therefore it's going to have a charge of -2 because it has 2 extra electrons. And if you have more electrons than protons, you become negative. Okay, so let's look at this question. So show the bonding between the following pairs of elements. Please use Lewis dot diagrams. Use the arrows to show electron transfer. And circle the electrons involved in sharing to represent covalent formation. So first we have to see, is it going to be an ionic compound with a metal and a nonmetal, or a covalent with a nonmetal and nonmetal. So here we have aluminum and sulfur, so let's go look at them. So aluminum is a metal, so it's going to be ionic compound, and it has, it's going to have, for the Lewis dot diagram, it's going to have 1, 2, 3 valence electrons. So it has a charge of +3, and you know that because it's in group 13, so it has 3 electrons. Sulfur is in group 16, so it's going to have 6 valence electrons. So aluminum 3, sulfur 6. So let's go and write these Bohr diagrams right now. So here's aluminum. Whoa, that was kind of weird. So 1, 2, 3, and then sulfur. Put up here. Sulfur is going to have 6. 1, 2, 3, 4, 5, 6. Okay, so we know this is an ionic compound, so sulfur is going to steal these electrons, so we can show that with arrows. Put an arrow over here. So here's 1 of the electrons that it's going to steal, and here is another electron that it's going to steal. So right now, the sulfur is happy, right? So it is a complete ion, and it has a charge of 2 negative. But is this aluminum happy? No, it's not happy yet. So what do we have to do? We have to add another sulfur. So we add another sulfur and put its 6 valence electrons because it's in group 16. Then let's put this electron over. Okay, now we have aluminum is all happy. So good for you, aluminum, you're happy. And you have a charge of +3. But now sulfur isn't happy. So we go back and forth until we have it all figured out. So we add another aluminum. Remember, it has 3 valence electrons. And now we can put this over. Okay, so now sulfur is happy. Good job, sulfur, way to be happy. But aluminum is still not happy. So what are we gonna do? That's right, back to the drawing board, add another sulfur here. And remember, it has 6 valence electrons. So put one more electron from aluminum, another one over. So now it has up to its 8. Remember, you need 8 to be happy. And it has a charge of -2. And this one here, it goes down to 8. So if you lose all your valence electrons, you also become happy. And so this has a charge of +3. So that is that one. So what would the formula be for if you combined aluminum and sulfur to make a compound? Well, you'd have 3 aluminums. So it'd be, or sorry, you have 2 aluminums. So it'd be Al2, and then it'd be S3. The question didn't ask you to do that, but just so you know. Okay, so now let's look at C and F. So C is right here, it's carbon, and it would have 4 electrons in its valence shell. And F is over here, and it would have 7 electrons in its valence shell. So C, 4 electrons, F, 7 electrons in its valence shell. And they're both nonmetals, so it's going to be a covalent bond. So C and F. So let's see what happens. So we'll put C. And it has only 4 electrons in its valence shell. Put them around like this. Then we have F, put one over here. And remember, it has 7. So 1, 2, 3, 4, 5. Oh, just for sake to make it easier, I'm going to go around this way so that our extra electron is right here. Okay, so carbon is going to share 1 with this fluorine over here, and because it's covalent, you're going to do this. So what does that mean? It means that now carbon has 1, 2, 3, 4, 5 valence electrons, and fluorine has 1, 2, 3, 4, 5, 6, 7, 8. So now fluorine is happy, and we don't give it a charge for this one because it's not an ionic compound. So now what are we going to do? Let's add another fluorine. So we'll add another fluorine here. And as you can imagine, the same thing is going to happen. It's going to share these. I'm not going to bother changing the color right now. Oh, I forgot to put all these ones though. So 1, 2, 3, 4, 5, 6, and then 7, 8. Okay, put another one right here. So fluorine has 7 valence electrons. So it's going to share this one. And one up here. 1, 2, 3, 4. Sorry, I'm rushing. Okay, there we go. Okay, so they all become happy, and so therefore the formula would be CF4. Okay, let's look at the next one. So right now we're going to come up with formulas for these different compounds, and remember the trick I taught you when you're naming compounds. So cold, toilet, paper. What does that stand for? Well, the C stands for covalent, the T stands for transition metals, and the P stands for polyatomic ions. So you're going to go here and you're going to categorize these into the type of compound they are. So the first one is nitrogen trihydride, and we know that because there's a tri here, it is covalent. So we're going to put a C for covalent. Is there a transition metal? No. Is it polyatomic? No, there's no polyatomic ion because it ends in "ide." So we know that it's not a polyatomic ion. Okay, the next one is dihydrogen monosulfide. So because of the prefixes, we know that it is also covalent. The next one, copper 2 nitrate. Okay, so there is a 2 here. So that means that it is a transition metal. And more specifically, it's multivalent, but I just use T for transition to really mean that it's multivalent. So T transition metal, and there's an 8 here, so it's polyatomic. So that means that it's going to have more than 2 atoms or 2 types of elements in the compound. Okay, here Gr.10 selenide, or however you say that. So there is a transition metal here, so we're going to put a T. Ammonium sulfide. So this here is a tricky one, but this here is a polyatomic ion. Okay, aluminum phosphate. So there's an 8 here, so it is a polyatomic ion. And nitrogen trifluoride, so there's a tri there, so it is covalent. So I highly encourage you to do that at the beginning of each section like this, because it will help trigger in your mind and remember how to do each particular type, because every type is a little bit different. Okay, so nitrogen trihydrate. These ones that are covalent are pretty easy to come up with a formula because it tells you the ratio is right in the name. So we have nitrogen, and because there's no di or tri in front of it, it's just a single one. And then trihydride, so there'd be 3 hydrogens, so NH3. It's pretty straightforward. The next one is dihydrogen monosulfide. So because it's covalent, same thing, it tells you the ratio. So we start off with hydrogen, and it's dihydrogen, meaning 2, and then monosulfide means there's just 1 sulfide. Okay, the next one is copper 2 nitrate. So we have copper, and we also have nitrate, which you should memorize, but if you didn't, you can look on your table of ions. So, table of polyatomic ions. So nitrate is NO3, and it has a charge of -1. So NO3, and remember it has a charge of -1. Remember, I like to put these in brackets and put the charge over here, so -1. And copper, well, we need to look up copper. Actually, no, we don't, because it's a transition metal, so it's telling us. So there's a charge of +2. So then remember, we just swap the charges. So we would put 2 over here and 1 over there, but we don't need to put the 1. And then after you do that, you can just erase this part up here. So you can just go and erase that so that you have just the chemical formula. But that's how you do that. Okay, so the next one, so gold 3 selenide. So let's see what we're going to do here. So let's go look up, actually we don't need to look up anything, I don't think. So we have gold, which is AU. You might need to look up the formula or the symbol if you don't know the symbol. And selenide. So we should look up selenide. So we know the charge of gold is +3. So +3. And then let's see the charge of selenide. Okay, so here's selenide over here. So remember, it'll have 6 valence electrons. So that means that to be happy, it needs to have 2 more electrons. So therefore, it has a charge of -2. So it also shows that right there. So there's a charge of -2. Therefore, you cross the charges, and the final answer will be AU2S3. And remember, you can erase these after you're done for the proper answer. Okay, the next one, ammonium sulfide. So the trick to remember is that ammonium is a polyatomic ion. So it is right here. It is NH4, and it is a charge of +1. So NH4. 4, and it has a charge, and like I like to do is just put these in brackets just to make it less confusing. So there's a charge of +1, and then sulfide is just sulfur because it has an ide, and there's no 8 in it, so you know it's not a polyatomic ion over here. So it's just S, and if you look at the charge of S, we did it up here. It's a charge of -2. So I'm just going to write it over here because I kind of made it a little messy. So the final answer then will be NH4 in brackets 2, because remember sulfur has a charge of 2, and then S. And there's no number, no subscript with the S because because ammonium is a charge of +1. Okay, next one over here, aluminum phosphate. So put Al and phosphate, so it's a polyatomic ion. So hopefully you remember phosphate is over here, PO4 with a charge of -3. And aluminum's here is a charge of +3 as well. So they both have a charge of +3, so therefore their charges will cancel out. So it'll just be AlPO3. And because you don't have to put a subscript with the phosphate, you don't need a brackets under it. So we can just leave it. So that's good. Okay, next one, nitrogen trifluoride. So we'll put N for nitrogen, and it's covalent, so it's telling us the ratios of each. So these ones are super easy if you recognize them. Fluoride, actually, wait, fluoride is just a F. Oops. So erase that L here. That'd be an easy way to get the question wrong. So, okay, F3. Oh. Okay, so there we go. So that's naming, coming up with the formulas. Now the next question is coming up with the names. So we want to do the same cold toilet paper method. So let's go through, and with naming, it's really important that we figure out what type of compound each of these are. So we have silicon and chlorine. So silicon is over here and chlorine is over here. Oh, that's a tricky one, isn't it? So is it covalent? Is it not covalent? That's pretty tricky. So if it's over here, you know what, on a test, honestly, I'd probably let it slide either way because I didn't tell you specifically. I don't think we went over a scenario like this, but let's just say that it is a metal. So silicon and chlorine. So we'll just leave it blank then. Okay, over here we have iron and we have chlorine. So remember, we're looking to see if it's a C, T, or P. And if it's neither, it means that it's ionic and it's blank. So this one is blank, so it's just a regular ionic, we'll call it. Iron is not covalent because it's a metal and a non-metal. Is it a transition metal? So let's go up and see if iron is a transition metal. Okay, so it is in the transition metal section, and in particular, you can see right here that it's multivalent. So therefore, we'll put a big T beside it, because remember, we're going to have to name it. And also, I'll put a brackets right in here right now, just to emphasize that I'm going to have to put a Roman numeral later. Okay, so next one is magnesium, and there's nitrogen. So let's see, so it's not covalent. Let's see if there's magnesium's a transition metal. It's over here, so it's not in the transition metal section. Remember, the transition metal section is over here. Yeah, so it's not a transition metal, and it's not a polyatomic because it only has 2 types of atoms. So this one is just another blank one. Now we have P and Cl, so let's check out those ones. So P is phosphorus. It's a nonmetal. Chlorine is also a nonmetal. Therefore, we're going to put C for covalent, because we're going to have to name these with the prefixes. So that's very important. Next one, nitrogen and oxygen. So nitrogen is here, oxygen is here. Those are both nonmetals as well. So put a C, and we'll have to remember, oh, I don't know what happened there. We'll have to remember to name them with the prefixes. And then right here, let's see, calcium and, oh, we have a polyatomic ion. We can tell that right away. And let's just double check to see if calcium is a regular metal or a transition metal. So where's calcium? Oh, it's close, but not quite. You can see right here that it's not a multivalent transition metal. So it's just polyatomic. So it's going to end probably in something that's an 8. and hopefully you've had this memorized. And then the last one, we also have a polyatomic, so it's going to end in something with 8 usually. And let's see if, just double check to see if this is a T, if it's a transition metal that's multivalent. So Pb, and as you can see, it's over here, and yes, it is. Yeah, actually, I should have extended this down here. But you can see that it is multivalent, so we'll put in transition metal. Okay, so now that we've done that, it'll be a lot easier to name them. So first one is silicon, and it's just a regular one, so we'll put silicon chloride. Okay, next one, iron, and we know it's iron, and we know that it's going to be chloride as well, but we don't necessarily know what the charge is going to be. So how do you figure out the charge? Well, you always start with this side and work backwards. So I like to just kind of put this in a bracket here, and we compare this side to this side. So this side, each chlorine has a charge of what? So up here, we'll look at it. Chlorine has a charge of -1, and there's 3 of them. So it has a charge of -1, but there's 3 of them. So that means this whole side is going to be -3. Over here, there's iron, and there's only 1. There's no subscript for it. So this whole side has to be worth 3+. And because there's only 1 iron, it means that each iron has to be 3+. So therefore, it's going to be iron 3 chloride. Okay, so let's look at the next one, magnesium and nitrogen, and we know that it's just a normal ionic compound, so we'll just go magnesium and nitride. Remember, we always change the last word, so that the anion, the negative ion, we put an IDE at the end. The first one we don't bother with. Okay, the next one over here, it's a covalent, so that means we're going to have to put our prefixes, that kind of thing. Let's look at that. So P, and these ones are kind of easy as long as you remember the different naming schemes for them. So how are you guys doing so far? Are you doing okay? Feel free to pause it and take a break if you want. You know, get a drink. Unless you're in class watching this, in which case, put that sandwich away. You can't eat in here. It's a science lab. Okay, so we have P and we have Cl. So therefore, we'll just put phosphorus. Remember, we don't have to put mono on the first word. So we'll just put phosphorus. Phosphorus, how do you spell phosphorus? I think that's how you spell it. And then chlor, and then remember we have to put the suffix to signify 3. So then it'll be trichloride. Okay, next one, we'd have di, because remember it's covalent as well, so dinitrogen. Okay, and then think about what 5 is. So it's penta oxide. Okay, the next one is a polyatomic one. So remember, it's not a covalent, so we don't use the prefixes anymore. So it would be calcium and this right here. So if you remember, you could go back up and look at it. Hopefully you're able to recognize that sulfate. So SO4. So sulfate. Okay, and then the last one here, I forgot to put in, it's a transition metal, so we need to put a Roman numeral in the middle. So over here we'll have lead. And over here we'll have, remember, this is also polyatomic, so you can think about, hopefully you memorized it, that it's called phosphate. So phosphate. Okay, and how do you know what charge the lead is going to be? Well, you start with this side. So this side over here, think about it like this. So every phosphate has a charge of what? So if you go back and look up at the chart, or if you have it memorized, every phosphate has a charge of 3 minus. But how many phosphates are on the side? There's 2 of them. So that means this whole side is going to have a charge of negative 6 minus. So that means that this whole side is going to have a charge of 6 plus. But that's for this whole side. So this whole side over here is going to have a charge of 6 plus. And how many leads are there? There's 3 of them. So that means that each of them is going to have a charge of 2 plus. Because there's 3 of them, each of them has a charge of 2 plus, so that will make a total of 6 plus altogether, and then the 2 sides will match, and that's what we want. So therefore this will be lead 2 phosphate. Okay, so now we're going to look at this section of the test, and it is looking at writing word equations for the following reactants, and then converting the equation to a skeleton equation, and also indicating the reaction type, so whether it's single displacement, double displacement, synthesis, combustion, or decombustion. So the first one here says calcium metal is added to water, and a vigorous reaction resulted, generating a base. So that's a good hint right there. So it's really important to read these questions carefully. So it generates a base and a gas. And also it tells us that a burning splint was added and a pop sound was heard. And so hopefully you can remember back to our lab and what type of gas you heard when there was a pop sound. So I'm going to start here with the word equation. So we have calcium and we have water. And then that yields, and that's what we have to think about. What does it yield? So to help us with that, let's come up with the skeleton equation. So we have Ca for calcium, and we have water, which is H2O. And then that yields, so we know it yields a base and a gas. So why don't we start off with the gas? So the gas, remember gases, so think about what it could be. It could be an oxygen, it could be a hydrogen, but we know that it makes a pop sound, and so that pop sound means that it must be hydrogen. And do we leave it like that? No, we don't, because it is a Brinkelhoff, so we put 2 there. So remember, Brinkelhoff is a little acronym for all the diatomic molecules. So we have BRINCLHOF. So those are all the different 7 elements that if they're by themselves, they always go with one other version of themselves. So instead of H by itself, because it's a Brinkelhoff, it's going to be an H2. Same with all these other elements. Okay, so it yields H2, and then we have to think about what type of reaction this could be. So remember, if you have A plus, let's say BC, then that's probably a single displacement, because then the nonmetal will switch with the nonmetal, or the metal will switch with the metal, that kind of thing. So in this case, we're using the metal switch with the metal, or in this case, it's the cation with the cation. So we'll have plus Ca, and then here's the hint. It said that it was with a base. So if it's with a base, it needs to have an hydroxide ion there. So it has to be like that, and now we just have to figure out the subscripts. So OH, if you look up at the top, hydroxide has a charge of plus or -1. I don't know why it's all messed up there. There we go, -1. And calcium has a charge of, let's go back up here, +2. So therefore, if we cross them, it would be CaOH and then 2. And remember, you have to have brackets around it, because if not, it's meaning that the H has a 2 and the O doesn't, where we want to say that there's 2 hydroxides here. Okay, so that is the skeleton equation. Remember, it means skeleton because it's not balanced, meaning that we don't have any coefficients in front of it yet to make sure that we have the same number of atoms on both sides. But we don't have to here. The question doesn't ask you for that. Okay, and then the type of reaction then, so it does follow that formula, so it would be a single displacement. So single displacement. Okay, now let's look at the next one. So we have barium chloride, and I'm going to start down here with the skeleton equation. So Ba and Cl. Let's make sure that we are doing the formula properly. So let's look up the charges for Ba and Cl. So Ba is, oh, I thought it was around here somewhere. There it is. So it is a charge of +2, and Cl has a charge of -1. So remember, if we cross those, we'll get the formula. So Ba has a charge of +2, so then we put that down here. And Cl is a charge of -1, so we put that down here. So BaCl2. So there's barium chloride. Then sodium sulfate, remember when we're naming them? So here is a polyatomic ion. So it'd be plus Na, and sulfate would be SO4 with a -2. So you can look up here if you forget that. And so this has a -2. And this has +1, so put a 2 right here. So Na2SO4. And then we have to figure out what that yields. So it says a white precipitate was produced. Okay, so there's a clue. And it also says after filtration, analysis of the remaining solution shows sodium chloride is also produced. So we know that there's some sodium chloride produced. So that is sodium and chlorine. And sodium has a charge of +1, chlorine has a charge of -1, so that formula is correct. So then we have to just figure out what happens with this one, the remaining things. So remaining, we have this right here, and we have this right here. So why don't we just put them together? So Ba and SO4, and let's just make sure that the chemical formula is correct. So Ba has a charge of +2, I think we determined before, and sulfate also has a charge of 2. It's a charge of 2-. So therefore, the charge is balanced out, and that is good. So what type of reaction it is? Is it? Well, we can see that basically the two cations swap positions. So the Na here went over here, and the Ba that was over here went over here. So it is a double displacement. So double displacement. And when you're writing it out, just be careful that there's no transition metals, and make sure you name the polyatomic ion correctly. So we have barium, chloride, plus sodium sulfate yields sodium chloride plus barium, I'm running out of space, but that's okay, sulfate. Okay, so that is that one. Okay, next one over here. So we have a solution of barium hydroxide, and we should be thinking about what type of compound it is. So hydroxide would generally mean that it's a base, and then it's added to a container containing nitric acid. So let's start off by putting these down. So BaOH, and remember OH has a charge of -1. Ba, as we just learned up there, has a charge of +2. So we'll have to cross them over and put a 2 there. And then nitric acid, how do you remember the formula for nitric acid? Well, you have to remember the formula for nitrate, because that's where this one comes from. So remember, nitrate is NO3. So if you look up here, NO3, and it's a charge of negative 1. So nitric acid is going to have that polyatomic ion in it, and it's also going to have what? What does an acid always have? It always has a hydrogen. So it's going to have that hydrogen in it. So those two are going to come together. And what type of reaction is this? If you have an acid and a base together, then that would be a neutralization reaction. So, right. Oh, I didn't even give that option here. But that will help you figure out what it is. So neutralization. Tricky. Neutralization. And I think I spelled that wrong. I apologize. Let's see. How do you spell neutralization? I should really know how to do this, shouldn't I? Neutralization. There we go. Sorry about that. Here we go. So neutralization. So that means that it's going to create water as one product. So H2O. And then it's also going to have an ionic compound of some sort. So the H was used over here already, and some of this stuff was used. So probably the Ba is going to go with this nitrate over here. So we could put barium. Oh, I'm not writing it out. I'm doing the formula. So barium nitrate. And barium has a charge of 2. Nitrate has a charge of 1. So we'll put this because we're crossing them over. So barium had a charge of +2 and nitrate had a charge of -1. We cross them over and there we go. Okay, so now we can write this out. So barium hydroxide plus nitric acid yields water, or if you wanted to be fancy, because it's covalent, you could call it dihydrogen monoxide plus barium nitrate. So remember, it's a polyatomic ion, so it ends in 8. Okay, so that's the first part of the test. Good job staying with it, and we're going to go over the second part in the next video.